Welcome back, friends. In this video, we'll look at one other enhancement of the Fruit Slasher game. This video is all about making use of the mouse or say the blade speed and direction. Now, this is a little bit mathematical, probably somewhat abstract to some of you. Hence, I will not write too much code here, but instead I'll just point you to some of the logic that we are using and some of the code snippets and how they can be used, right, from the enhanced game. So let's get started. Now, the whole point is, remember, in this game, the mouse or the mouse pointer is used to slash the fruits. And you may also recall that we have these two lists, mouse X and mouse Y. These lists contain where all the mouse has been for the last 5 positions. That's how we've done this in our game. Mouse X and mouse Y both contain the X and Y position respectively. X0, Y0 being the oldest and X4, Y4 being the latest, right? And with this list, these two lists available, we are doing certain things. For example, we are figuring out if the mouse is moving or not. And remember, since mouse is acting like a blade, it's like same as whether the knife is being used to slash or is just standing in one position. So questions that we can answer from this list, and one of them we are doing, in fact, is that is the mouse moving? If yes, can we say how fast is it moving? Right, and I'll talk about this later. Can we also somehow figure out which direction it has been moving in? Right, so these are like some extra questions that we can ask, and we can build them into the game. Like I said, this could get a little bit mathematical, but I'll try to explain this slowly and show you the code snippets for this. Right. So first thing first, how do we determine if the mouse is moving or not? Right. The method that we used in the class was that and it's logical that if all elements of both these lists are exactly the same, the mouse is not moving, right? So which is logical. If nothing is changing, it means the mouse has become static, right? If any one of the list elements are not equal, that means that the mouse is moving. And we can see this, in fact, I can show you, this from the class game. Basically, if I, let's say, turn on this thing and nothing moves here. If I move my mouse alone, notice uh, all the lists, every element of the list has become the same, right? On the other hand, when I move, then these things start to change, right? Now, this is precisely the logic we are using over here, that if the elements of both the lists, so this and this, are exactly equal to the mouse X and mouse Y, that means that there is no movement. So there's no moving. We set moving to 0, else we set moving to 1, right? So that's what we have done. And this K keeps incrementing. So we are checking every element and making sure it's equal to the mouse X or mouse Y, right? So that's fine. But now the question comes that assume it is moving, right? Assume it is moving. Um, how can we figure out if the mouse is moving fast or slow, right? Now, if you think about it, right, this list is really containing all the places that mouse has gone, right? So when we move our mouse very fast to the screen, let's say I've given an example here. If the mouse is say moving very fast, then these points are going to be very far from each other. On the other hand, if the mouse is moving slowly, then these points are going to be close to each other, right? Near each other, basically, right? And as you know, if the mouse is not moving at all, which is like an extreme of moving slowly, then all these points will be basically on each other, and hence nothing would change, right? So which means that what I'm trying to get at is that if we find the distance between these points, then we can figure out how fast the mouse is moving, right? And what we can do is, in fact, is that we can just look at the last two elements, right, which is the x4 y4 and x5 y5, and measure this length, and that will give us the distance that the mouse has just traveled in the last instance, right? For those of you who have learned Pythagoras theorem in mathematics or coordinate geometry, you will recognize that this distance will be given by this rather intimidating looking formula, but nothing to be scared. It's just some mathematics which you will learn eventually. It's a famous result coming from this Pythagoras theorem, right? Now, like I said, this is strictly speaking, this is distance, not speed, but it's useful for us, right? So let's see how this can be done, and I'll show you this piece of code from the uh, you know um, from the enhanced game. Basically, what I'm doing is that I'm computing, using the mathematical operations. This rather humongous looking operation, but I'm doing exactly that. I'm looking at the element 5 and element 4 and finding that's exact quantity, right? And it's best to see this, so this particular calculate speed my block, I have put it also inside forever, right? So I have this calculate speed forever being done, and now we can see this, right? In this particular code, let's say I turn on this thing called blade speed. So when I do this, notice when the mouse is stationary, the blade speed is also 0, which is understandable because blade is not moving. But then when I move it slowly, it's kind of becoming 0, 1, 2. But if I move it really fast, notice it becomes quite large, right? It becomes like sometimes maybe hundreds, something like that, right? So say 16, 17. And that's because when I move fast, then I just basically make many more, these points end up quite far from each other. I mean, it's kind of, when it's moving slowly, notice quite small, usually you say 1 point something. And when it's very moving large, it's kind of becoming larger numbers, right? Yeah, you have to observe this, but that's true, right? Uh, Now the question comes that the next question that I would ask is that, if I were to know that this mouse is moving, all right, how can I tell if it's moving in which direction, right? Now you can actually imagine, if you really think carefully about it and if you apply a little bit more mathematics, you can in fact figure out from these points which direction is the mouse going in, right? We can in fact precisely figure out in a two-dimensional space what is the direction that the mouse has been heading in the last 5 steps, and which direction the mouse is going, you can figure out from there, right? But that mathematics can get quite involved, so we can take a simpler approach. We can ask ourselves a question: is the mouse moving only horizontally, or is it moving only vertically, right? So which means that, the way it could be done is that, let's say I have these two lists, mouse x and mouse y. If the mouse is moving only horizontally, then we'll find that only mouse x values are changing, right? So which is because if the mouse is moving horizontally, which means that only the x value is changing, the mouse y will stay constant. Similarly, if the mouse is moving vertically, then only the y value of the mouse y, only the mouse y values will change. Mouse x will not change, right? But so yes, technically this can be done, but if we really try to do this, if I, let's say, show you this list, mouse x and mouse y, uh, here, notice that when I try to even move horizontally, sometimes my y is changing, sorry, so x is changing a lot more, there's no doubt, but even y sometimes changes because my hand cannot be as stable as I would like, right? So similarly, if when I move up and down, x is mostly constant, it's changing much lesser than the y, but still it changes because my hand kind of shakes a little bit, right? It's natural for all of us, right? So which means that if we were to really determine direction, then we have to think of some method of figuring out some other way of doing this movement, right? And one of the ways to do movement, and again this is a little bit mathematical but logical also, is that what I can do is that I can compare, let's say, in the last 5 moves, right? In the last 5 places, the has the list changed? For example, I can compare, has the value, have the values in the list changed? Which means, for example, if I compare, let's say, the fifth value of the mouse x and the first value of mouse x versus the fifth value of mouse y or first value of mouse y. So, yeah, mouse y. So going back to this diagram, what I'm trying to say is that if I compare, let's say, this x1 and x5 and y1 and y5, right? If I compare these two and I find that these two are very close to each other, then I can say that the mouse has not moved much in, say, x direction or y direction, right? So I can keep some kind of a threshold, and I say that, okay, look, if this is more than a certain number, then we can say mouse is moving in that direction, right? So this way we can figure out if the mouse is moving in x and y direction. It's a little bit more reliable because it, for example, one or two elements, if it's changing, then we can kind of say that, okay, there's no movement, it's just natural shaking of the hand, right? And with that, what we can do is that I can basically, what I've done here is that I have written this code called max xy move. And what I'm really doing, sorry, what I'm really doing with that is that, I'm setting this to the absolute value of 5 minus 1. And again, this absolute value means that, whether it's positive or negative, I take it as a positive because I'm really just trying to figure out how much real deviation there has been, right? So I find out how much I moved in the x, how much I moved in the y, and now I try to start questioning. I try to start forming this kind of a logic, right? That if max x is less than 10, which means if I move less than 10 positions in the x direction, right? Remember, max x is given by, max x is given by item 5 minus item 1. And this is being done forever because I've called this inside a forever loop here, max xy move, right? So if this is done forever, if max is less than 10, then I say, okay, I'm not moving in the x direction. So I'm moving x is 0. And similarly, if I'm moving more than 10 times, then I say moving x is 1, right? And this seems logical. I can actually show you what's going on. Let's say if I open by the way, I'm looking at these variables here. So I'll say, for example, let's say I look at moving x and say max x, right? Now, when I look at these two variables and I say turn on my game, as I turn on this game, so when x is moving, notice when I'm moving horizontally, moving x is 1, right? But on the other hand, and max x is also changing, right? If I keep it stationary, everything becomes 0. But if I move very little, then max x is kind of very small and moving x is not considered so it's not considered movement in the x direction, right? And similarly, I can do the same thing on the y direction. If max y, the same logic actually as applied on the y direction, then I can figure out if it's moving in the y or the x direction, right? Now, this alone is not sufficient. In fact, I can now do some more inference from this. Let's say I'll make a truth table here, right? That let's say I'm moving in the x direction, moving the y direction. Yes and yes. If this is the case, then definitely I'm moving. However, am I moving only vertically? Well, the answer is no, because I'm also moving in the x direction, right? So it means I'm moving something like in a diagonal way, right? Because x is also changing, y is also changing. On the other hand, let's say I'm moving in the x direction, but not moving in the y direction. Certainly, I'm moving, right? But I'm not moving vertically, because clearly I'm just moving in the x direction, right? Uh, our other way, I'm moving, not moving in the x direction, but I'm moving in the y direction. It means yes, I'm moving. So certainly I'm not stationary, I'm moving. However, I'm moving only vertically. On the other hand, if I'm not moving in x direction, not moving in y direction, it means that I'm not moving. And obviously, if I'm not moving, then I'm also not moving vertically. Now, this again could be a little bit abstract, but you think through it, each of these conditions will start to make sense, right? And that's exactly what we have done here. We have said that okay, if moving y is equal to 1, which means I'm moving vertically, and I'm not moving in the x direction, right? And not moving x equals to 1, or I could say moving x equals to 0, right? In that case, I'm moving vertically. And similarly, if moving x and moving y, that means if both of them are 0, then moving is 0, else moving is 1, right? So, this is exactly what we had done earlier, but this is slightly different now, right? Now, the question that comes up is that how can I use all this in the fruit slasher game, right? Now, yes, it's very good that I've been able to figure out if the blade is moving at a certain speed, if the blade is moving in a certain direction and all that. I'll give you, like I said, I'm not going to write too much code here because this is a little bit abstract, but all these are my blocks inside, forever. So they are always working. What I'll show you is, okay, just a moment. Yeah, so I've got these 4 conditions. Let me just bring them up a little bit so that it's clear what I'm trying to do. Okay. Yeah, I have to be a little bit careful here. Yeah. So let's go to the, oops. All right, so I'll look at 4 conditions here and we'll go through one by one. Now I'm going to hide some of these variables, I mean the list particularly, so that becomes easier for me. Remember, the whole thing is being used to decide whether a particular fruit has been slashed or not, right? So at the simplest level, in fact, we are not even doing this in the class. We are keeping it a little bit more complicated in the class, but at the simplest level, I could say if touching color, whatever color, right? Say touching color, in this case, gray, right? Then I say I'm touching a fruit. Remember, this whole code is for finding the fruit has been slashed and creating the remaining clones as they are needed, right? Now, in this case, what I can do is that I can basically keep my mouse stationary, right? I mean, blade is stationary, and even if I just click on this, notice the moment I click on this, the fruit gets slashed, right? It just happens to touch this, and so in which case it's just like it will always pretty much always slash because I'm not looking at the speed, right? Now let's say, so this is like the simplest level. What we have done in the class is that not this, but in fact we have said and moving equals to 1, right? So I'll just make my variable moving also visible here. Let's say moving and moving vertically. I'll make these two available here. So basically moving indicates if the mouse is moving or not. And I can hide this max x, right? Now what happens is that if I just did, let's say exactly this. So remember when I'm standing in one place and shooting, notice that the fruits actually do not get slashed. So let's just see it carefully. If I just move it one position and slash, nothing happens. That's because I need this to be moving. However, even a little bit of movement will just do the trick for us, which is why it looks like this is not really working. But actually it's working, right? Because if I just keep it completely stationary and try to slash, nothing will happen like now, right? But with a little bit of movement, we'll just get it done, right? Now let's say I add a condition that not only do I want this Y to be moving, I in fact want it to be moving at a certain speed, right? So I could probably replace this condition, make it even more stringent, and I can say that, okay, look, if the speed is more than, let's say, 4. And how did I come with 4? I just tried to experiment a little bit. But to make my point clear, I'll make it very, very large. Let's say I say speed is, let's say, more than 1000, which is impossible, right? You'll notice that even though everything is happening, the fruits will almost never get slashed, right? So that's because the speed never becomes so large, and it will never become this large because speed ultimately is a distance between two. Like I said, the 4th and 5th element of the list is not going to go beyond 1000. So the slashing is never happening. It's unrealistic, but I could certainly do something like maybe say I could try say let's say if I try 8, see what happens, right? I expect to see some slashing happening now. in fact, the game starts to behave kind of normally. But if I go very slow, for instance, right, I'm moving, but I turn quite rapidly. So if I go very slow, it's just going to, you know, uh, just going to roll over it, right? So not going to slash, right? As I showed you, if the speed is very large, then it's not going to slash, right? I mean, if the limit is very large, it's not going to slash, right? Now let's say we go further and say that, okay, look, the speed should be over a certain number, and also I should not be moving vertically, right? So here, notice I've set the condition that these two happen. So speed, say, let's say more than 8 I can make, or say 10, and I am not moving vertically, right? So basically, if I go, like, if I'm going horizontally, then obviously moving vertically is 0. But if I go vertically, completely vertically, then this becomes 1, right? Now the reason this becomes 0 occasionally is because I also stop, right? So this becomes 1. So in this case, what will happen is, if I just go vertically, notice my, even the speed is reasonable, many times my fruit will not get slashed, right? Now obviously none of this is going to be perfect, but it's still quite illustrative, quite interesting to think about what's going on, right? If I go completely vertical here, nothing's going to get slashed, but if I go diagonally, it will get slashed, right? So this is how we can use it in the game. A little bit difficult, but good to think about, good to implement. I hope you found this useful. Take care. Thank you so much. Bye bye.